Use the definition of the parabola directly to find the equation of a parabola with focus 2, comma 2 in the directrix. The line x plus y plus 2 is equal to 0. So first we're going to plot this. I'm just going to show you graphically what this looks like, and then we're going to talk about the definition of a parabola to see really what we need to derive the correct equation. Okay, notice that the directrix is not going to be a horizontal or vertical line. Okay, in fact, this equation, if you write it in mx plus b form, this is a linear equation, obviously, because the directrix is a straight line. You subtract x and 2 on both sides, so you're going to get minus x minus 2. Okay, so if we plot this, it's going to be negative x minus 2. Okay, negative x minus 2. You know, minus 2 is going to be the y-intercept, and the slope is negative 1, right? So we know that it's gonna look something like this. Okay, so this is what this is gonna look like. This is gonna be the equation. Y is equal to minus x minus 2, right? So this is gonna be the directrix. Okay, this is the line. Now, the focus is 2, comma 2. Notice that it's going to be perpendicular. The line connecting, the line segment connecting the focus 2, comma 2 and the directrix shows perpendicular relationship, right? So this line segment that you connect with the directrix and the focus is perpendicular to the directrix line, as it should be. So this is the focus, 2, comma 2. We can mark it F. And we know that the vertex should be halfway between the focus and the directrix line, right? So halfway, so I should say it should be about here, right? So that would be the vertex. Okay, and we know that the parabola is opening away from the directrix, right? So it should look something like this. Okay, so in any case, now let's talk about the definition of the parabola. So the definition says that the parabola is a locus of points, and any such point on its locus is going to be equidistant from the focus and equidistant at the same time from the directrix line. So what I'm saying is, if we choose this point, for example, the distance, I know it doesn't look like the same distance, but it doesn't matter. You see, this is not exactly drawn to scale the way I drew the parabola, but what basically the definition states is that these distances should be the same. Okay, so we can mark these line segments being congruent. Okay, and not only this point, but any single point that you choose on this parabola is going to be drawn in such a way that the distance from that point to the focus will be the same as the distance from that point to the directrix line. And again, this is not drawn to scale. Remember, the parabola is not drawn to scale. It's not drawn very well. Okay, so knowing that definition, we can use the distance formula. Okay, we can use the distance formula, and we're going to do a great job with it. So first of all, we need to mark any point on the parabola x comma y. So we're going to say be a point on the parabola, right? So if we let x, y be a point on the parabola, any arbitrary point on the parabola, okay, and locus of all these points is what defines the parabola, right? The locus of all possible points like that. But let any arbitrary point be x comma y. Then we can use the distance formula. So we know that x minus 2, right? So we're talking about this distance here, squared, plus y minus, now the y coordinate of this focus is also 2, squared. Now we've got to talk about the distance, setting this distance between the focus and the point on the parabola with the distance between the point on the parabola and the directrix, right? And that distance, we're not going to use the distance formula. We're going to use the distance from a point to a line formula, right? So we know that formula is what? So x plus y plus 2, right? We copy that directly. Okay, we copy that directly. And that will be divided by 1 squared plus 1 squared, right? So we know that we're using the distance from a point to a line formula here. Okay, and the way to understand it is that you're replacing basically this x with the x given, this y with the y given, and the 2 stays, right? But we know that if we replace x with this x, it's the same thing, right? It's the same thing. So basically, why replacing? Because we're talking about the coefficients of the x being multiplied to the x coordinate, the coefficient of the y in this equation being multiplied by y coordinate, but the fact is that the coefficient of the x and y are both 1, and instead of the numbers, we have x and y. So as a result, we just copy this over, x plus y plus 2. Okay? And then on the bottom, as the formula says, we should take the coefficients of the x and y in this equation and simply square them and take the square root of that sum, right? So a is equal to 1 here, b is equal to 1, right? So a squared plus b squared gives us 1 squared plus 1 squared because the coefficients of x and y are both 1 here. Okay? So that's how we get this result. So now as a result, we can square both sides. If we square them, look what's going to happen. We square both sides. As a result, we will get rid of the square root here. X minus 2 squared plus y minus 2 squared is equal to, now squaring the absolute value is the same thing as just squaring the inside without the absolute value bar, right? That's fine. Because we know the absolute value makes sure that it's going to be positive, that it's going to be non-negative, right? So if you square the non-negative is the same thing as squaring the inside, because squaring will still give you positive. And squaring the square root gets rid of the square root. 1 squared plus 1 squared is 1 plus 1, which is 2. Multiplying both sides by 2 will eliminate the 2 in the fraction, so the fraction will not be there anymore. Right, so the 2's are gone, but the left side becomes, let's see, so we can expand this, x squared minus 4x plus 4, that's for this, plus 2. Now remember, I forgot to indicate that we multiply everything by 2, not just the first term. So 2 times now y squared minus 4y plus 4, right, that's for this guy, is equal to, now let's expand this guy squared, the top. There's no more fraction. X squared, the first product, plus y squared, the second product, plus 4, the third product. And then two products of x and y being added, so plus 2xy. 2 products of x and 2 being added, so plus 4x, right? 2x times 2 is 4x. And finally, 2 products of 2 and y, so that's 4y. Okay, and I believe this is it, because we already had the last product 2 times 2. Okay, so now we get 2x squared minus 8x plus 8 plus 2y squared minus 8y plus 8 is equal to x squared plus y squared plus 2xy plus 4x plus 4y plus 4. I just did it in order. So as a result, we're going to subtract everything on the left side. Minus 2xy minus 4x minus 4y minus 4, right? So I'm going to write everything down so you see what we're subtracting. And minus 2xy is just, you know, minus 4x minus 4y. Right, and minus 2xy, why not? Okay, So if we do that correctly, look what's going to happen. As a result, we will have x squared. I'm going to write minus 2xy next. And then instead of 2y squared, we get y squared. And then minus 8 minus 4x minus 12x. And then minus 12y. And then let's see if we get 16 minus 4, which is 12, is equal to 0. So this is your equation of a parabola with the given focus 2, 2, and the directrix, the line x plus y plus 2 is equal to 0, right? So whatever parabola that you see here, even though it's not drawn to scale, but the equation of this parabola is exactly this, what you see here. Okay, so I hope this was useful. Thank you so much for watching, and see you in my other videos.